but we haven't seen one actually do anything.
Yeah, so actually we of course talk off screen as well. This may be actually a good time to do the actual pair programming where we actually modify the code, because the first thing I did was compile the app and play tic-tac-toe, and I usually like to tie when I play tic-tac-toe, and the game just...
Please.
I want the middle.
Okay. I'm going to go there.
I'm going to make it easy for you to block me, I guess.
Please do, because I know
So-
that actually...
So that we don't actually accidentally win.
Mhm.
Alright, and it's a draw. Oh, somebody fixed it.
Whoops!
Ah! No, it was a bug when I was doing
That's
it.
what happened.
Oh, well,
Alright.
that was a PR merge between I downloaded the
I didn't
app.
merge that though.
Well, we can still step through the code
Yeah.
in the test to,
Tell you what we'll do is I'll show you where the bug was and where the fix was. How's that?
yeah, it's fine. I'm happy that it actually works. Oh, hold on, can you go back and make sure that when it's a draw, you can like restart the game or exit. Okay, there are. Okay, you're not stuck. Basically, just to explain how it looked like when it was still buggy. When I put the last X in it,
Yep.
it asked for O to play,
Yes.
and O is like I can't play. There's nothing I can do here. But why I wanted to do this?
So
Oh,
here's the most
okay.
recent commit that was not supposed to... God, did I actually merge that? I really did.
Well then,
I'll tell you what. Let's check out the buggy version just to show that so we can see what happened.
sure. The reason why I wanted to do that is because it, I hope, demonstrates the advantage of having your state machine completely separate from your UI element, so we can iterate on fixing a bug without necessarily playing tic-tac-toe over and over
Yeah.
again to make sure that we tie, because that's, gets boring after a very, very quick round or two.
Don't accidentally win.
Yeah, don't win. Remember not to win.
There we go.
Okay, so that's how it used to look like, and
Exactly.
you are stuck because the state machine will bounce you back to the same state if you try to click on a
Yep.
place that already is taken,
Yep.
and there's no place that's not taken, so you can't do anything.
Right.
Alright, let's actually try to fix the bug on screen instead of secretly fix it overnight and check it in.
I'm
Alright,
happy to do
so,
that. So one cool thing about this particular, that made me excited when you told us you found this bug that we're going to cleverly was that I actually had a unit test for that should have caught this bug. And so what I told you was, oh, no problem, that's unit tested, so I know it must work in the state machine, so it must be an integration problem somewhere. But I was wrong, because when I looked at my unit test, and this is the take turns reactor test, we test that we can read and write the game, we test that we can start the game with the names and they'll show up, we test that somebody can win, we test that last behavior we got into where if you click on states that were already chosen, we just don't do anything, we test that you can quit, never tested that you can have a draw.
Alright then, so I happen to have the behavior that is not tested.
Exactly.
I like to draw.
So we are hiring for QA if you get bored with like consulting and you want to run a QA department. No offense to our QA department. So I'm going to quickly, we're going to do some red-green test stuff here, and I'm going to bring in the test that we should have written to actually catch that. So
let's close off this panel so
Yeah.
that we have more room.
So this is our new test. We're going to test that there's actually a draw. And the way we're going to do that is we're going to create a state. So this is the take turns reactor test. The take turns reactor is a state machine, creates a workflow that models taking tic-tac-toe. So
And is that a sub-workflow of the play game workflow?
yes. So
you're not kidding when you said that
No,
the
we're
shell
not.
one doesn't know how many
Yeah.
levels does this inception go.
Yes, this is why this is a terrible sample app, because it does everything. So yeah, so we've got a hierarchy of the shell workflow, could be running the run game workflow, which might be running the take turns workflow. But this is the leaf, this is the bottom.
This is a little bit off topic, but
Mhm.
I wonder if like you can generate a dependency graph of all the workflows.
Oh, yes.
Ooh.
Yeah, we can do that.
So when you have onboard a new team member, they have a visual of how all these things are composited together,
Yeah.
and maybe even the state machine itself. So per state machine, you can see it the inner working of it, and then the whole top level workflow.
I don't know if we could actually get the state machine itself out.
We could at least show the states and stuff.
Yeah.
We can definitely.
Self-documenting code is the best kind. Is all I'm saying.
Yeah.
So,
And we
sometimes,
also
yeah,
we have some really good logging stuff that's going on where we can watch Logcat and we can see what state are we in, just keep dumping that stuff out. What event came in, how to transition. All of these states are Kotlin data classes, so they have beautiful two-string methods. So even if we can't like statically generate the cube circles and lines, we can dump.
So everything. I can imagine having the crash reporter have that information, so you can actually reproduce bugs.
Yes.
Because that's the number one problem when you get an incoming crash report and you have a stack trace. How do you get there? I don't know.
I've got a branch actually that will also spit out a trace file that you can use Chrome's trace viewer, and you can actually see a timeline of like which workflows you were in and when they changed states.
We should have to show that off.
Wow, all right. So maybe there will be a sequel to this once the 1.0 always arrive. Because I'm excited. That's the worst. I mean, that's exactly why I was excited about using a state machine to drive my app, is because of all those things, right? Once you detach the UI from the logic, you can do so much on the pure logic.
Exactly.
All right, I got distracted, sidetracked, but let's look at the reactor. And,
right. So we're going to take turns reactor. Our state class is a thing called turn, and it's actually not a sealed class. It's just a complete description of what's going on right now. So it includes a map.
It's not required for the state to be a sealed class.
It is not. Sometimes we have a state machine whose state is unit because there's just nothing for it to do except wait for an event and then do something like that. It's we've tried very hard not to be
imposing on people how they want to model their
exactly.
state. That's interesting. Yeah, because it makes sense because for me it doesn't make sense initially, but now that I see that the turn contains the board and the board is an array
of... And the board is barely even that. It's a list of these player enums. So player is X or O, and board is basically an alias for list of players.
Wait, what? That's a board? I thought the board is a 3x3 grid.
It is.
But it's a list of players?
So player is X or O.
Oh, I see. So this is the content of the square, not Zach.
Exactly. Yeah. It's a very simple model of a person. They're either the X person or the O person.
Okay.
And then the turn is basically has three parts. It's got this little map of what is the name of the X player and what is the name of the O player. Whose turn is it? It's either X's turn or O's turn, and then it's got the 3x3 grid of the X's and O's. So, and then when we're taking a turn, here's our React method. We're either being told to take a square, in which case we run the take an X or take an O and decide if somebody won or not, or else somebody quit. In which case we say we finished this workflow and the game is over. It was the result type. And the result condition was somebody quit rather than somebody won or it was a draw.
Mm-hmm.
So that's all what's going on there. So we go back to our unit test now of this thing.
Yeah.
So the way we're setting up our test is we create the state, the turn of the, all the squares are filled in. Here's our board, remember, if you're right, it's just an array of arrays.
Mm-hmm.
We got all our X's and O's and there's one blank spot left. And then we expect that when X takes that last spot, the last turn is going to be just like the one that we started with players named Higglety and Pigglety, and X is the person who's playing, and it'll be a full board. So to run the test, we create the take turns reactor, we tell it to launch, that same old method. We tell it this is the state we want you to start with, and
that's the initial state parameter.
Exactly. What is it?
And then the workflow pool is just a bunch of workflows available, so that if the take turns reactor needs to delegate to another workflow, it can do that.
That's basically, this is workflow runtime is the way to think about that. this is the machinery that gets passed around.
Well, yeah. I mean, workflow pool is actually a good name, except that whenever I see pool, I think of threads and executors and thread pool.
Right.
Because that's the only pool I really use. So initially when I look at it, that's where my mind went, and then I have to bring it back. It's like, no, it's literally a pool of workflow that I can then use to handle. Yeah.
You can think of a workflow
Something.
too as like a thread or like a process that's running some stuff and eventually finishes. And so in that case, then yeah, you've got a bunch of these
So
processes.
my mind was actually on the right track, except it also confused me. Okay.
Yep. This is excellent feedback.
The
So
workflow pool thing is also probably going to
Could
change.
change, which I expect because it was confusing to me, so I'm hoping that will change.
Yep.
Yeah.
it was confusing to a lot of people. So remember that workflow had that state property, which gave you the stream of screens that we're going to show. Well, it also has a result property, which is the thing that actually, when we call finish with, result is the single that fires when the workflow finishes. So when the workflow is done, result is what fires to tell you how it finished. In the case of the take turns workflow, it finishes with here's what the last turn was, here was the state of the board, here's who won, that kind of a thing. And so our test is we've created the workflow, and the workflow is in this state. We create it, and then we send an event. We want you to take this square in row 2, column 1, because we're programmers and everything is 0 indexed.
Right, of course.
And then our test is, okay, it should have been finished by now, and the result that came out from the result field should have been a completed game in the draw state, and the board looked like this. And of course, if we run this test,
It will run quickly, first of all, I need to mention that.
Yes.
And then it fails.
Right, and it fails because, where did it fail? It failed at line, the workflow should have been finished, it should have terminated, but it didn't.
Right,
which
that's
is
why I
what
was
saw.
stuck with a like give me a thing.
Right.
And